Okay, so for this lesson here, we're going to be looking at multiplication of radicals. This is not too bad. You just got to make sure that you group things together, kind of like we did for division. It's very similar for multiplication. I know that's backwards, but this video wasn't recorded, so we'll start here. This is just the basic property rule for multiplication. As you can see, they just do a general rule here. But as you can see, they are taking our coefficients of A and C and multiplying those together separately, as well as taking the radicals of root B and radical of root D and multiplying those together underneath one radical. So if we were to do this example with numbers, say if we had 3 root 5 times that by, we'll do 4 root 3. So again, if we follow the same general rule, I'll use the same colors too to keep things organized. If we take our constants, we separate those together and multiply them. I'll write those in black, so 3 times 4. I don't know what happened to that 4 there. And then green to highlight our square roots, we get root 5 times root 3. So then I'll write that in green. So parentheses, a giant square root, and it is 5 times 3. So that being said, then we need to simplify this. So 3 times 4 is 12. And then the square root stays, and then we multiply 5 times 3, and that is root 15. So make sure you're breaking things apart. That is the most helpful thing. If you have colors as well, do that. That is helpful. For problems like these, you also need to pay attention to this radical right here. So if this number underneath the square root is able to do a factor tree, you need to do so. But with 15, you can't do so because it's just 5 and 3. So that means they're both lone pairs. So that means they stay underneath. So you multiply those together, you'd still get root 15. So that means 12 root 15 is your solution. Okay, so moving on, here's another example that they walk us through. So I'll do the same color of highlighting everything. Again, it is 3 root 6 times 4 root 5. So first you want to look at our constants and separate those. So we get 3 times 4, which I think those were the numbers I just chose by accident. Of course they were, but that's okay. And then we want to look at our square roots. So we get root 6 and root 5. Again, we separate those and put those underneath the square root. So it'd be 6 times 5. And then they simplify. 3 times 4 is 12. And then the square root of 6 times 5, which is root 30. So again, like I said, it's not too bad. We just need to remember to stay organized. What do we got here? These more examples. Okay, so these are just more examples. So again, I'll do the same pattern of using highlighting. Again, we have to look at our coefficients. So 2 times 3 gets separated, and then we look at our square root value. So root 10 times root 6, so square root of 10 times 6. So they do a really good job of keeping this organized. Okay, I see where this problem's a little different. So you get 6 root 60. And like I said at the beginning, you need to double check to see if your radicand, so which is underneath the square root, can be factored. So using a factor tree. So they didn't really do a factor tree, so I'll kind of do one, but it'll go sideways if that's okay. So they did 4 and 15. And then 4 can be split to 2 and 2, so we can cross that out. And then again, we know that we circle our pairs. And when we have a pair, that means it goes on the outside. So you can see all the way down here. It goes on the outside. Then anything that is a lone, you can put in a box, you can put a dot, it doesn't matter. But that means that stays inside the square root here. So that is where they got that from. And then this 6 was already there, so that just gets pulled down. So it's 6 times 2, where they got 12. And then root 15 stays, and that's where they got 12 root 15. Multiplying here, this one, the only difference is underneath the square root, there is a higher degree for our variable. So we have x squared here. That being said, it's the same exact step. So you want to look at your coefficients. So you got 2. Well, this time the coefficient is with a variable, but that's okay. But our coefficients are 2x and 5. So you multiply those together and you get 10x. Then for our square roots, we get root 6x and root 3x squared. That being said, same thing, you keep the square root. And then you do 6x times 3x squared. And we know when we multiply exponents together, we add them. So we have 1 plus 2, and that's where they got x cubed. And then 6 times 3 is 18. Again, the 10x was not touched, so that stays the same. And then this is just putting all our knowledge back together, which we've been doing. So factor trees, again, they did for 18, so that's 9 and 2. And then this goes to 3 and 3. I know it's really crammed on here. But we have a pair of 3s, so that gets pulled out in front, which they did here. And then there's an x cubed, so that means there's x times itself 3 times. So that means if there's a pair of x's, that also gets pulled out in front. So that is why it is 3x being multiplied to our 10x here. So that's where they get the 30x squared, because 10x or 10 times 3 is 30, and x times x squared. And then what is left underneath here is just the root 2x, so that just gets pulled down here. I'm pretty sure on your guys' quiz you won't be seeing anything like that. That's a little bit more complex, but it's just putting everything together that we've learned so far. Okay, so trying some on our own here. Again, I'll do the highlighting. So our coefficients of 2 and 5. So we get, again, I like to put in parentheses, so 2 times 5. And then in the second parenthesis, I already know there's going to be a square root. But we get root 10 times root 3, so 10 times 3. Okay, so we simplify this out, we get 2 times 5, which is 10, and then the square root of 10 times 30, or 10 times 3, which is 30. I believe if we do a factor tree, it does not work, because if we did, say, 10 and 3, and then 2 and 5, so yeah, there is no factor tree to do for this one, so it stays the same. So then your answer would just be 10 root 30. Okay, looking at the next one, following the same process of using a highlighter or colors or something. First, you want to look at our coefficients and put those together. So we get 3 times 2. And then next we want to look at our square roots. We get root 8 and root 6. So root 8 times 6. So simplify this, we get 6. And then the square root of, what is that, 8, 16, 20, 48. Again, use your calculator. I'm just doing mental math, but you can follow along with me or pause the video if you want to attempt these beforehand without me. Then we got to see if we can do a factor tree for this. I know already that we can do 12 times 4. This can be 4 times 3, 2 and 2. And then don't forget to cross these out so you don't get confused. And 2 and 2. So we get to the bottom of our tree, so we got to find our pairs again. So we have pair of 2s, pair of 2s. And we get 1 loner 3. So I'm going to rewrite this over here. We have a 6 out in front, but now we have 1, 2 we're pulling out for this group, and then another 2 for our second group, and then a root 3 because that is left by itself. So 6 times 2 is 12, times 2 again is 24, and then square root 3 stays the same. Okay. So then we can do one more. We're not going to do D because I do not believe you're going to be seeing that on your quiz. These are larger numbers. That's okay. I'll have to use a calculator too. So we have, again, our coefficients 4 and 5. So we're going to have 4 times 5. And then lastly, our square root. So root 12 times root 18. Root 12 times 18. I'm going to just take a guess. 12 times 12 is 144. I'm going to go 256. Let's see. 12 times 18, 216. That was close. Not really. So simplify this. 4 times 5 is 20. Then we get the square root. What did I say? 216. This one's probably going to be a large factor tree. I don't know where this is going. So it ends in an even number, so at least I know it's divisible by 2. So that means we get 108 over here. Again, this ends in even number, so it's divisible by 2. 54, we're getting there. And 54 is 27 and 2. 27 is 9 and 3. And then 9 is 3 and 3. So this one's a lot longer. You won't be seeing this long ones on your quiz or anything. But just to show you. Okay, just to highlight some pairs, I'll do them in blue. So we have a 2 here and a 2 here. So there's a pair. And some 3s down here. So we got those pairs. And then we have one loner 3 and one loner 2. So now if we rewrite this, let me scroll down a little bit. So we already have 20 out here, so I'm going to rewrite 20. I'll pull that down so you know where it's coming from. And then we have a pair of 2, so we pull out 1, 2, a pair of 3s, pull that out. Anything that's a loner stays in, so we have 1, 2, and a 3. Then all we got to do is simplify this. So 20 times 2 is 40, 40 times 3 is 120. And it's a square root of 6. I said 120 and wrote 12. But 120 root 6 is your solution. That's all I got because this next one's kind of hard. We'll skip over that one because I'm almost positive that's not on your quiz. But if you have any further questions, please get in contact with myself, Mr. Browning, or contact Mr. Rayola. Also come into office hours because the quiz is Friday.